Talofa tamaiti, our year 9 math lesson today is from strand algebra, substrand simplifying algebraic expressions in addition and subtraction. During the lesson, some of the clips from Professor Khan is slotted in for enhancing the lesson. First of all, tell me students, what is algebra? Okay. It is simply the study in mathematics that involves letters of the English alphabet, that is A, B, C up to W, X, Y, Z. These letters represent numbers. An example of an algebraic expression can be 3x plus 4y equals 10. As you see, there are two letters or two variables there, x and y. The key words that you should be familiar with are like terms and unlike terms, coefficient, and the power of a variable. Okay, let's recall our prior knowledge. Like terms and unlike terms. Like terms are terms of the same letter, or commonly called a variable with the same power of the letter. For example, 2x, 3x, negative 4x. All of them are power of 1. Or a, 2a, 3a are all power of 1. And they are like terms. Likewise, the last a square, 2a square minus 3a square, or a to the power of 2, 2a to the power of 2, negative 3a to the power of 2. They have the same letter and the same power. So those are some examples of like terms.
Let's say that you started off with 3 apples, and then I were to give you another 7 apples. So my question to you, and this might be very obvious, is how many apples do you now have? And I'll give you a second to think about that. Well, this is fairly basic. You had 3 apples. Now I'm going to give you 7 more. You now have 3 plus 7. You now have 10 apples. But let's say I want to do the same type of thinking, but I'm too lazy to write the word apples. Let's say instead of writing the word apples, I just use the letter A. And I say, let's say, and this is say a different scenario, you start off with 4 apples. You start off with 4 apples, and to that, I add another 2 apples. How many apples do you now have? And instead of writing apples, I'm just going to write A's here. So how many of these A's do you now have? And once again, I'll give you a few seconds to think about that. Well, this also might be a little bit of common sense for you. If you had 4 of these apples, or whatever these A's represented, if you have 4 of them and then you add 2 more of them, you're now going to have 6 of these apples. But once again, we started off assuming that A's represent apples, but they could have represented anything. If you have 4 of whatever A represents, and then you have another 2 of whatever A represents, you'll now have 6 of whatever A represents. Or if you just think of it, if I have 4 A's, and then I add another 2 A's, I'm going to have 6 A's. You can literally think of 4 A's as A plus A plus A plus A. And if to that I add another 2 A's, so plus A, that's 2 A's right over there. How many A's do I now have? Well, that's 1, 2, 3, 4, 5, 6. I now have 6 A's. So thinking of it that way, let's get a little bit more abstract. Let's say that I have 5 x's. Whatever x represents. X could be some number. So I have 5 of whatever that number is, and from that I subtract 2 of whatever that number is. What would this evaluate to? How many of these x's would I now have? So it's essentially 5x minus 2x is going to be what times x? Once again, I'll give you a few seconds to think about it. Well, if I have 5 of something and I subtract 2 of those away, I'm going to have 3 of that something left. So this is going to be equal to 3x. 5x minus 2x is equal to 3x. And if you really think about what that means, 5x's are just x plus x plus x plus x plus x. And then we're going to take away 2 of those x's. We're going to take away 2 x's. So take away 1x, take away 2 x's. You are going to be left with 3 x's.
Whereas unlike terms are terms with different letter or different powers. For example, 2x is not the same as 2a. They're not like terms, so as negative 3w. Or 2a, 3a squared, and 3a to the power of 5 and a to the power of 4 are all unlike terms.
Now we have a very, very, very hairy expression. And once again, I'm going to see if you can simplify this. And I'll give you a little time to do it. So this one is even crazier than the last few we've looked at. We've got y's and xy's and x squareds and x's and, well, more just xy's and y squareds and on and on and on. And there will be a temptation, because you see a y here and a y here, to say, oh, maybe I can add this negative 3y plus this 4xy somehow, since I see a y and a y. But the important thing to realize here is that a y is different than an xy. Think about if they were numbers. If y was 3 and an x was a 2, then a y would be a 3, while an xy would have been a 6. And a y is very different than a y squared. Once again, if the y took on the value 3, then the y squared would be the value 9. So even though you see the same letter here, they aren't the same. I guess you cannot add these two or subtract these two terms. A y is different than a y squared, is different than an xy. Now with that said, let's see if there is anything that we can simplify. So first, let's think about the y terms. So you have a negative 3y there. Do we have any more y terms? Yes, we do. We have this 2y right over there. So I'll just write it out. I'll just reorder it. So we have negative 3y plus 2y plus 2y. Now let's think about, and I'm just going in an arbitrary order, but since our next term is an xy term, let's think about all of the xy terms. So we have plus 4xy. Right over here. So let me just write it down. I'm just reordering the whole expression. Plus 4xy. And then I have minus 4xy right over here. So minus 4xy. Then let's go to the x squared terms. I have negative 2 times x squared, or minus 2x squared. So let's look at this. So I have minus 2x squared. Do I have any other x squareds? Yes, I do. I have this 3x squared right over there. So plus 3x squareds. And then let's see, do 2y. I have an x term right over here. And that actually looks like the only x term. So that's plus 2x. And then I only have one y squared term. I'll circle that in orange. So plus y squared. So all I have done is I've reordered the statement and I've color-coded it based on the type of term we have. And now it should be a little bit simpler. So let's try it out. If I have negative 3 of something plus 2 of that something, what do I have? Or another way to say it, if I have 2 of something and I subtract 3 of that, what am I left with? Well, I'm left with negative 1 of that something. So I could write negative 1y, or I could just write negative y. And another way to think about it, but I like to think about it intuitively more, is what's the coefficient here? It is negative 3. What's the coefficient here? It's 2. We're obviously they're both y terms, not xy terms, not y squared terms, just y. And so negative 3 plus 2 is negative 1, or negative 1y is the same thing as negative y. So those simplify to this right over here. Now let's look at the xy terms. If I have 4 of this, 4 xy's, and I were to take away 4 xy's, how many xy's am I left with? Well, I'm left with no xy's. Or you could say, add the coefficients. 4 plus negative 4 gives you 0 xy's. Either way, these two cancel out. If I have 4 of something and I take away those 4 of that something, I'm left with none of them. And so I'm left with no xy's. And then I have right over here, I could have written 0xy, but that wouldn't, that seems unnecessary. Then right over here, I have my x squared terms. Negative 2 plus 3 is 1. Or another way of saying, if I have 3 x squareds and I were to take away 2 of those x squareds, I'm left with 1 x squared. So this right over here simplifies to 1x squared, or I could literally just write x squared. 1x squared is the same thing as x squared. So plus x squared. And then these, there's nothing really left to simplify. So plus 2x plus 2x plus y squared plus y squared. And we're done. And obviously, you might have gotten an answer in some other order, but the order in which I write these terms don't matter. It just matters that you were able to simplify it to these 4 terms.
A variable. A variable is any letter of the alphabet. Remember, as I said before, it represents numbers. And lastly, a coefficient. Coefficient is a number in front of a variable. Power of a variable is a number at the top right-hand corner of a variable. Example, 16a to the power of 6. So the power here is 6. Very important note. Keep this in mind, students. You cannot add or subtract unlike terms. When adding or subtracting like terms, you add or subtract their coefficients. In other words, numbers in front of the variables or numbers in front of the letters. Simplify the following gives example here. First example is 2s plus 3s plus 7s minus 4s. They are all like terms, so we can do the math by adding and subtracting the coefficient, which comes out to be 2 plus 3 is 5, plus 7 is 12, 12 minus 4 is, and the answer is 8s. The second example, 3a to the power of 2 plus 2a to the power of 2 plus 4a to the power of 2 minus 5a to the power of 2 is equal to, first 3 plus 2 is 5, plus 4 is 9, 9 minus 5 gives you 4, which is 4a to the power of 2. Again, note that all those terms are like terms.
Let's say that I've got 2 Chuck Norrises, or maybe it's Chuck Norri, and to that I am going to add another 3 Chuck Norrises. So I'm going to add another 3 Chuck Norrises, and this might seem a little bit obvious, but how many Chuck Norrises do I now have? Well, 2 Chuck Norrises, we can represent this as literally a Chuck Norris plus a Chuck Norris. So let me do that, a Chuck Norris plus another Chuck Norris. 2 Chuck Norrises, you could also view this as 2 times Chuck Norris, and this is just another way of representing it. And 3 Chuck Norrises, 3 Chuck Norrises, you could view that as a Chuck Norris plus a Chuck Norris plus another Chuck Norris. And so we would have a grand total, and this might be very simple for you, but you would have a grand total of 1, 2, 3, 4, 5 Chuck Norrises. So this would be equal to 5 Chuck Norrises. Now let's get a little bit more abstract here. Chuck Norris is a very tangible thing. So let's go to a little bit more of traditional algebraic notation. If I have 2 x's, and remember, 2x, this is what you could do this as 2x's or 2 times x, and to that I were to add 3x's, and to that I would add 3x's. How many x's do I have? Well, once again, 2x's, that's 2 times x. You could view that as an x plus an x. We don't know what the value of x is, but whatever that value is, we can add it to itself. And then 3x's are going to be that value. Let me do that in that same green color. 3x's are going to be that value plus whatever that value is. And so how many x's do I now have? Well, I'm going to have 1, 2, 3, 4, 5 x's. So 2x plus 3x is equal to 5x. And if you think about it, all we really did, and hopefully you conceptually get it, is we just added the two numbers that were multiplying the x. And these numbers, the 2 or the 3, they're called coefficients. Very fancy word, but it's just this constant number, this regular number that's multiplied by the variable. You just added the 2 and the 3 to get your 5x.
5s to the power of 2 plus 3b minus 2s to the power of 2 plus 2b. To make it, to cut down the mistakes, you collect the like terms, put them in the front. For example, 5s squared plus 3b minus 2s squared plus 2b. To minimize the mistakes, you bring forward you put them together in like terms so that it cuts out the mistakes. So what I've done here, I bring forward the negative 2s squared to group with the 5s squared. So 5s squared minus 2s squared plus 3b plus 2b, and it gives you 5 minus 2 is 3s squared, 3 plus 5 is 5b. That's simplified form. Remember, you cannot add like terms, so s is not like term with b. Answer stops there. That's how simplified it is. Okay, another example is 2w to the power of 3 plus 3z to the power of 2 plus 3w to the power of 3 minus 2z squared. Again, putting the like terms first and group them into like terms, we have 2w's to the power of 3 plus 3w to the power of 3 plus 3z to the power of 2 minus 2z to the power of 2. And 2 plus 3 gives you 5w w to the power of 3 plus 3 minus 2 gives you 1z to the power of 2.
Now let's think about this a little bit more. Let's go back to this original expression, the 2 Chuck Norrises plus 3 Chuck Norrises. Let's say to that we were to add, let's say we were to add some type of a, let's say we were to add 7 plums over here. So this is my drawing of a plum. So we have 7 plums plus 2 Chuck Norrises plus 3 Chuck Norrises. And let's say that I add another 2 plums. I add another 2 plums here. So what would this whole thing be? Well, I wouldn't add the 7 to the 2 to the 3 plus the 2. We're adding different things here. You have 2 Chuck Norrises and 3 Chuck Norrises, so they're still going to simplify to 5 Chuck Norrises. And then we would separately think about the plums. We have 7 plums, and we're adding another 2 plums. We're going to have 9 plums plus 9 plums. So this simplifies to 5 Chuck Norrises and 9 plums. Similarly, over here, if I had, instead of just 2x plus 3x, if I had 7y plus 2x plus 3x plus 2y, what do I now have? Well, I can't add the x's and the y's. They could very well represent a different number. So all I can do is really add the x's, and then I get the 5x, and then I'd separately add the y. If I have 7 y's, and to that I add 2 y's, I'm going to have 9 y's. If I have 7 of something and I add 2 of something, I now have 9 of that something. So I'm going to have 9 y's. So you add that. Do that in a different color. You add this and this, you get that. You add the x's, you get that right over there. So hopefully that makes a little sense. Actually, I'll throw out one more idea. So given this, what would happen if I were to have 2x plus 1 plus 7x plus 5? Well, once again, you might be tempted to add the 2 plus the 1, but they're adding different things. These are 2 x's. This is just the number 1. So you really just have to add the x's together. So you're going to say, well, I got 2 x's, and I'm going to add 7 x's to that. Well, that means I now have 9 x's. And then separately, you would say, well, I've got just the abstract number 1, and then I got another 5. 1 plus 5 is going to be equal to 6.
U to the power of 4 minus 3v to the power of 3 plus 2u to the power of 4 plus 5v to the power of 3. Note that u to the power of 4 are like terms with this 2u to the power of 4. So when you put them together, like in the following steps, you put u4 plus 2u4 to the power of 4 minus 3v to the 3, or to the power of 3 plus 5v to the power of 3. Now you can add these two like terms, which is 2 plus 1 gives you 3. And negative 3 plus 5 gives you a 2. So the answer will be 3u to the power of 4 and 2v to the power of 3. Okay. Example 6. We have 2ab plus 3ac plus 3ab and 2ac. Or 2ab plus 3ac plus 3ab plus 2ac. Again, you bring forward the 3ab to group with a 2ab, while the 3ac and the 2ac can come after. Like for this example, 2ab plus 3ab plus 3ac plus 2ac. So now 2 plus 3 gives you 5, and you got a 5ab and a 5ac. There it is, 5ab plus 5ac. Example number 7. We have 6g to the power of 2 plus 3s to the power of 2 minus 3g to the power of 2 plus 2s to the power of 2 plus 2g to the power of 2 plus 4s to the power of 2. Again, you bring forward the g's first before you list the s after. So the next step would be, this is to minimize making mistakes. So 6g to the power of 2 minus 3g to the power of 2 plus 2g to the power of 2 plus 3s to the power of 2 plus 2s to the power of 2 plus 4s squared. So 6 minus 3 plus 2 gives you a 5g squared. And then 3 plus 2 is 5 plus 4 is 9s squared. So the answer is 5g squared plus 9s squared. And of course you can't add unlike terms. They're both unlike terms. So okay, let's go to the next one. Example 8. We have 4m squared plus 3n squared minus 2m squared plus 5n squared minus m squared plus n squared. Can you bring forward the m's and then followed by the n's? As in this case, 4m squared minus 2m squared minus m squared plus 3n squared plus 5n squared plus n squared. And now if you deal with the m squared first, you go 4 minus 2 is 2 minus 1, you're left with m squared. 3n squared plus 5n squared plus 1 squared gives you 9n squared. And there you are. Guys, m squared plus 9n squared is the answer of simplification of this. We have 2p to the power of 3 plus 3q to the power of 2 plus 3p to the power of 2 plus 2q squared minus p to the power of 3 minus q to the power of 2. Again, you put all the p's in the front and the q's after that. Example here. Here we are. 2p to the power of 3 plus 3p to the power of 3 minus p to the power of 3 plus 3q to the power of 2 plus 2q to the power of 2 minus q to the power of 2. 2 plus 3 is 5 minus 1 is 4p. And 3 plus 2 is 5 minus 1 is 4q squared, and 4p to the power of 3.
I've gotten feedback that all the Chuck Norris imagery in the last video might have been a little bit too overwhelming. So for this video, I've included something a little bit more soothing. So let's try to simplify some more expressions, and we'll see we're just applying ideas that we already knew about. So let's say I want to simplify the expression 2 times 3x plus 5. Well, this literally means 2 3x plus 5s. So this is the exact same thing as, so this is 1 3x plus 5. And then to that, I'm going to add another 3x plus 5. This is literally what 2 times 3x plus 5 means. Well, this is the same thing as, if we just look at it right over here, we have now 2 3x's. So we could write it as 2 times 3x plus we have 2 5s. Plus we have 2 5s. So plus 2 times 5. But you might say, hey, Sal, isn't this just the distributive property that I know from arithmetic? I've essentially just distributed the 2 times 3x 2 times 3x plus 2 times 5? And I would tell you, yes, it is. And the whole reason why I'm doing this is just to show you that it is exactly what you already know. But with that out of the way, let's continue to simplify it. So when you multiply the 2 times the 3x, the 2 times the 3x, you get 6x. You multiply the 2 times the 5, you get 10. So this simplified to 6x plus 10. Now let's try something that's a little bit more involved, but once again, really just things that you already know. So let's say that I had 7 times, let's say, 3y minus 5 minus 2 times 10 plus, let's say, plus 10 plus 4y. Let's see if we can simplify this. Well, let's work on the left-hand side of the expression, the 7 times 3y minus 5. We just have to distribute the 7. So this is going to be 7 times 3y, which is going to give us 21y. Or if I had 3y's 7 times, it's going to be 21y's, either way you want to think about it. And then I have 7 times, we're going to be careful with the sign, this is 7 times negative 5. 7 times negative 5 is negative 35. So we've simplified this part of it. Let's simplify the right-hand side. So you might be tempted to say, oh, 2 times 10 and 2 times 4y, and then subtract them. And if you do that right and you distribute the subtraction, it would work out. But I like to think of this as negative 2. As negative 2, and we're going to distribute the negative 2 times 10, and then we're going to distribute the negative, or times 10, and then negative 2 times 4y. So negative 2 times 10, negative 2 times the 10 is negative 20. So it's minus 20 right over here. And then negative 2 times 4y, negative 2 times 4 is negative 8. So it's going to be negative 8y. So let's write a minus 8y right over here. And are we done simplifying? Well, no, there's a little bit more that we can do. We can't add the 21y to the negative 35 or the negative 20 because these are adding different things or subtracting different things. But we do have two things that are multiplying y. We have the, let me do them all in this green color. You have 21y's right over here. And then from that, we are subtracting, or we can view it as, from that, we are subtracting 8y's. So 21 of something, if I have 21 of something and I take 8 of them away, I'm left with 13 of that something. So those are going to simplify to 13y's. And then I have negative 35. This in a new color. And then I have negative 35 minus 20. And so that's just going to simplify to negative 55. Negative 55. So this whole thing simplified using a little bit of the distributive property and combining similar or like terms. We got to 13y minus 55.
That is our lesson for today, students. Hope you have learned something new. Stay safe till fast 4.